solving a depressed cubic equation like this. We're just going to do ones that are in the form x cubed equals something x plus something else, is a pretty involved process. The process is to solve, to create a system of equations where 3ab is equal to whatever this number is, in this case 18, and a cubed plus b cubed is whatever this other number is, which is 35. And if you can solve that system of equations for a and b, and you add them together, you'll get this, one of the solutions to this question. So just for reference, so we know we're right, 5 is the answer to this question, because 5 cubed does equal 18 times 5 plus 35. And a and b are going to become 2 and 3, because 3 times 2 times 3 is 18, and 2 to the third plus 3 to the third is 35. So how do we get that? Step 1 is to divide both sides of this equation by 3a, to get 18 over 3a, which reduces to 6 over a. Then substitute for this b in the second equation, substitute 6 over a for that. Turn that into 216 over a to the third equals 35, and then multiply everything through by a to the third. And then bring everything over to one side. Now we have a 6th degree equation, but it's a special 6th degree equation because it's kind of like a quadratic, because a to the 6 is the square of a to the third. So it becomes a cubed squared plus 35. I'll just put this a cubed in parentheses so you can see the structure there. Now you can do the quadratic formula, equals negative b plus, I'll let you don't have to write the minus because we only want one answer for a anyway, the square root of minus 35 squared minus 4 times 1 times 216 over 2. Uh, 35 squared is 1225. 4 times 216 is 864. 1225 minus 864 is 361. And 361 is actually a perfect square. 19 times 19 is 361. So I end up with a cubed equals 35 plus 19 over 2. 35 plus 19 is 54 over 2, which is 27. So a is equal to 3. If a equals 3, you can substitute that back in to b equals 6 over a is 6 over 3, which is 2. So a and b are figured out. So that means that x is 3 plus 2, which is 5, which is the answer to this question. If I do one that's more involved, and I'm just going to go straight, well, I'll write down the equation. 3ab equals 6, and a cubed plus b cubed equals 40. This is eventually going to become the equation a to the 6 minus 40 a to the third plus 8 equals 0, which is going to become 40 plus the square root of 1568 over 2, which actually becomes 20, I'll choose plus the square root of 392. This 1568 can be written as 4 times 392, and the 4 can come out as a 2. So that means a becomes something pretty ugly. is the cube root of 20 plus the square root of 392. Now, as far as getting b goes, I'll tell you, if you get an ugly expression like this, the b value is going to be the same expression, except this plus is going to be a minus instead. So the answer to this question is the cube root of 20 plus the square root of 392 plus the cube root of 20 minus the square root of 392. Funny thing about this is that this is actually equal to 4, although it's not clear why, but the answer to this question is definitely 4. 4 cubed minus 4 cubed is 64, and 24 plus 40 is also 64, so this must be an ugly way of saying 4. Now there is a shortcut for getting straight to the answer. The answer always looks like this. It's just a matter of getting this number, which is the same for both, and this number, which is the same. Well, this first number is always going to be half of whatever the constant is. So 40 over 2 is 20, so that goes here and here. To get the other number, you take what you just got, the 20, and you square it, and you subtract the 6, you divide that one by 3, and you cube it. And you get 400 minus 8, which is 392. Gets us right to the answer. So the final thing about this unit is what would happen if I had not a depressed cubic, but a full cubic, a complete cubic. Well, the trick is that you replace x with y minus b over 3. b is positive 6. This is not the same b as before. This is calling the coefficients a, b, and c. So in this case, it's y minus 6 over 3, which is y minus 2. If you replace all three x's with y minus 2's, 6. Cubing this is a bit annoying, but there is something called binomial expansion, where it's the first term cubed and then 3 times the first term squared times the second term, plus another 3 times the first term not squared times the second term squared, plus minus 2 to the third. Of course, we could do FOIL for that other one, y squared minus 4y plus 4. This other one, you could just distribute the 6 through. And if you do this carefully enough, you'll get y cubed minus 6y minus 40 equals 0, a depressed cubic. This ends up canceling out with when you multiply the 6 and y squared. If you rearrange this as 6y plus 40, this is a question we can do by just trial and error to know that the answer is 4 for y, or you could get that real ugly expression that equals 4. Either way, we got the solution for y. We're not done yet, though. Remember x was y minus 2. So in this case, it's 4 minus 2, which is 2. And 2 is the answer for this original question. So that's how you solve cubic equations.